Welcome back in submodule 1.5. Here we will discuss about the priority handling between overlapping resource and the radio resource selection. Right? So there are two concepts here we are going to discuss. How the handling done in case of overlapping resource and how radio resource selection will trigger. So let's move on. Okay, priority handling between overlapping resource. So, keyword again, overlapping of resource. So, it is normal concept that when someone or something will be overlapped, there is always a chance to have the collision. There is always have a chance of the collision, and this is what is happening here. Resolve conflict when UE has multiple concurrent resource allocation. Right, so there is always chance of the overlap, there is a chance of the conflict, right? And that conflict, how we overcome it, that is what we are going to discuss it. So let's try to understand with the example. UE receives two grant overlapping in the time, so same time, there is just same time. So let's assume that your SFN is 500 and the slot is could be your 10. Okay, so 500/10. Okay, here grant is allocated for EMBB services. So there we have defined it the multiple services. One service is EMBB, enhanced mobile broadband, another service is for the URLC. As we know, as per the 3GPP table, the priority of the URLC is high compared to the EMBB, but the grant is allocated on the same slot or same time. What will happen? What will happen? So grant 1 10 millisecond slot for EMBB and having the priority 2. Grant 2 is allocated for the same slot for URLC services and having the high priority. So there is a always chance of the conflict. So here conflict is happening. Resource is allocated to whom? What MAC will do, MAC will select grant 2 for URLC. Why it will select grant 2? Because of the priority of the services. Due to priority of the services, it must receive the grant first, right? And it may ignore the EMBB. It may ignore the EMBB or can drop the grant 1, right? Because the grant is allocated on the same time. So at a time only one it can allocate. Either it can allocate to these services, it can allocate to these services, right? So due to the high priority, MAC will take decision to allocate resource to this one and it will drop to this one, right? So this is how it's called priority handling between overlapping of resource. If there is a no overlapping, no issue, but in case overlapping triggers, then this is how the intelligence comes of the MAC layer. Now let's move on the radio resource selection. This is very good example of how resource allocation selection will be done. So explanation is about the autonomous modes where the side link is there, side link communication is there, and this is the latest communication right now. Industry is exploding with the vehicle to anything. Okay, so in this case what MAC will do, MAC will select the time and the frequency resource without G node B scheduling. Interesting, it is telling that MAC will select the time and the frequency domain resource without G node B scheduling. Okay, wait for a moment. Usually what is our understanding? What is our understanding? If UE having the some data to transmit UE request for the scheduling request, then scheduler allocates the grant, right? The allocation of the grant by the GNode B is mandatory. Without resource, you cannot transmit the data. But here we are discussing the time and the frequency domain resource without GNode B scheduling. How it will be possible? But there is a possibility, and let's try to understand the Example is side link V2X. First, I will discuss about the side link because we need to understand the concept before moving in this part. What is side link? It is also called as D2D communication. D2D communication, direct to direct communication. What does it mean? What happening in this case? In this case, where UE, basically UE, exchange the data without routing through the G node B. Usually what is happening? UE communicate to the G node B, right? Usually UE communicate with the G node B because this is part of the RAM. UE communicate with the G node B if they have to establish the signaling, if they have to transmit the data. But in this case, D2D communication, there is a user 1 and there is an end user here, right? It will bypass the G node B and it will communicate directly here, right? Why it will do that? Why this concept, such type of concept introduced? The reason is that to reduce the latency. To reduce the latency. Less the node it has to transmit, latency will reduced, right? So that is the end goal of this concept. Now, when we are talking that you bypass the G node B, right? So question comes in mind, at what interface? What interface? So 3GPP has given the new interface for G2D communication, and that interface is PC5. That interface is PC5. It is going to be used. So we know overall that the side link is also known as D2D communication. D2D communication used to reduce the latency because it bypassed the G node B, and the interface it used is PC5. Now let's move on. The scenario: vehicle needs to broadcast safety data. Okay, what Mac will do here? Mac will use the sensing based selection. Okay, it will sense the information, it will sense the data, and then it will monitor resource pool. Monitor the resource pool. What does it mean? As we have discussed here, you will not wait for the Gnode B seedling to allocate the resource. Then what are the possibility? There are only two possibility are there. Possibilities. Let's discuss the possibilities. Possibilities. One possibility is that we should have, or we configured the predefined set of resource position. Predefined. Predefined. We define the resource. We define the resource position in the time domain and the frequency domain. And based on that, you will already knowing in the advance that where I need to transmit, because due to the predefined set of resource position. Another way is that we define the pool of the resource pool, RP, resource pool. We define it, and then randomly you can pick the resource from this resource pool, and in this case it does not wait for the Gnode B to allocate the grant, and then it can transmit the data, and that is what is happening in this case. Okay, let's move on. Here this is the summary of what 3GPP has given in the specs. Let's see that the function downlink, uplink, sidelink TX, sidelink RX. First, mapping between logical channel and transport channel. We have already discussed it. Wherever you see the cross, right, it means that it supports. So downlink, uplink both support. Sidelink, TX, RX supports. Multiplexing, we have discussed it. Demultiplexing, we have also discussed it. Shielding information reporting, discuss. Error correction through the HARC, we have already discussed. Logical channel prioritization, we have discussed. And the radio resource selection, we have already discussed. So radio resource selection only support in the side link TX side, not on the RX side, right? So this is how overall summary we can understand from this table. So hope all the concept which we have discussed in all the sub-module is cleared. In case still you have a question, you can comment. Thank you.